So in this problem, there's a simple pendulum. This bob is of mass m, and this thread is of length L. So a physics teacher pulls the bob until the thread makes an angle 2 by under root 3 minus 1 radian with the vertical. So this bob is pulled until this thread makes angle theta naught, and theta naught equal to 2 by under root 3 minus 1. Fine. Now when this bob is pulled to the angle theta naught, uh, the teacher applies continuous force F equal to mg along the circular path. And up to when this force is applied. So this force is applied until the thread again comes to vertical. So thread was vertical initially, then it was pulled to this angle theta naught. Now it's pushed back again to its original position, this position where the thread becomes vertical. But now there's a force F which is always applied perpendicular to this string. Fine. So we have to find the time t in which this bob will reach to its original position again. So let's see how to solve this problem. So this is thread and this is the bob of mass m. Initially this angle is theta naught. This angle is theta naught. Now let's say when the thread comes to an angular position of theta, what will be the forces applied on thread? One force will be mg and another force will be F. One thing is that this F will always be perpendicular to this thread. Now if I will take torque about point A, which is on the ceiling, let's say how will these forces contribute to the torque. So this angle is theta, so this angle will also be theta, so this angle will be theta. So torque of mg will be mg sine theta into L about point A, and torque of this force F will be independent to theta because this force acts perpendicular to the thread always. This force always acts perpendicular to the thread. So torque due to this force will be F into L. So this torque will be equal to moment of inertia, which is equal to ml square into d square theta by dt square. Fine. Now replace this force by mg because it's given that this force is equal to mg. So mg L taking common, sine theta plus 1 equal to ml square d square theta dt square. This m and this m will cancel out, and 1 L from this side and 1 power of L from this side will be cancelled out. So the equation will be L into 1 plus sine theta equal to sorry, this L will be cancelled out, equal to L theta double dot. Now we can approximate this theta or sine theta to be theta. So 1 plus theta equal to L theta dot. What's the reason behind this approximation? So the maximum angle which the bob is pulled throughout is equal to theta naught equal to 2 by under root 3 minus 1. So when you calculate cos theta naught, this cos theta naught will be equal to open your calculator and see the value of this cos theta naught. So this cos theta naught will come to be 0.99999963878. So which is approximately 1. So this theta naught will be small, very small. So sine theta can be approximated as theta, because the initial angle theta naught, which was the maximum angle, is equal to uh, is approximately equal to 0, and further this theta will be decreased when the bob comes to vertical position. So further angles will be smaller than this. uh, so sine theta equal to theta naught can be approximated. So now we have to solve this equation. For solving this approximation, for solving this equation, let's take 1 plus theta equal to p. So theta dot will be equal to p dot, and theta double dot will be equal to p double dot. P will be equal to lp double dot. Okay, so we have one missed one g here. G was also here. So gp equal to lp dot. Now this is our known SHM equation. Also one minus sign was also there, because this theta is decreasing. Minus sign, minus sign. P will be equal to p naught cos omega t plus phi. This is solution to our standard SHM equation. Now let's see the initial conditions. So theta at t equal to 0 equal to theta naught. This is our initial condition 1. And theta dot at t equal to 0 equal to 0, because at theta equal to theta naught, when time equal to 0, there's no angular velocity to the bob. Fine. So we will apply these two initial conditions. So p equal to p naught cos phi. And what was p? P was equal to 1 plus theta equal to p naught cos phi. This theta equal to theta naught. So 1 plus theta naught equal to p naught cos phi. Uh, and applying the second initial condition, let's differentiate this. So p dot equal to minus p naught sine omega t plus phi, and 1 omega will come outside. So p naught will be multiplied by omega. So what's p naught? So p naught equal to theta naught from here. So theta naught, which is equal to 0 at t equal to 0, will be equal to minus p naught omega sine phi. So minus p naught omega sine phi equal to 0. This implies that phi equal to 0. Now we will put this phi equal to 0 in this equation. So 1 plus theta naught equal to p naught cos phi cos 0 equal to 1. So p naught equal to 1 plus theta naught. So p equal to p naught cos omega t plus phi. So p was equal to 1 plus theta, and p naught comes to be equal to 1 plus theta naught into cos omega t plus phi. Now what we have to find? We have to find that when theta equal to 0, means the thread becomes vertical. What's the time at that moment? So 1 equal to 1 plus theta naught. Theta naught we will put 2 by under root 3 minus 1. This was our initial angle, into cos omega t. T we have to calculate, and phi we have calculated to be 0. So this one and this minus 1 will cancel out. So 1 equal to 2 by under root 3 into cos omega t. So root 3 by 2 equal to cos omega t. This means that omega t will have a value of 5 by 6. And now we will put the value of omega. So omega was equal to g by l. From here, uh, from this equation, we can say that omega will be equal to g by l. So under root g by l. G by L into T equal to pi by 6. So T will be equal to pi by 6 into under root L by G. So this is our answer.